Hello, everybody. Welcome to our version of Virtual Night Sky for, oh my gosh, it's the last day of November, November 30th, 2022. Not only is it the last day of November, but this is the last week of classes, formal classes at ASU for the fall semester. So everything's kind of a little bit busy around and everybody's getting ready for their finals and all of that. And so we also had a little year-end party for our staff today. And so we're a little bit sort of just coming together, and we've got a great show for you tonight. But Kim Baptiste is going to join us a little later. And Meg Hufford's going to join us a little later also because they're wrapping up some of the festivities. With me, though, on this particular program is Alex Blanche. You've probably known him since we started about a couple of years ago. And he'll be handling the polls for us. And he's kind of working the background tonight, taking double duty and kind of covering the web master job today. Armand Dalla is here, too. And both of them will have a role in the program tonight. My name is Rick Alling, and you know me as the manager of the Marston Exploration Theater and community outreach projects for the School of Earth and Space Exploration of the ASU Tempe campus. We love doing this particular program, and tonight we're going to go back to Planet Watch. There's some things coming up this month that are very exciting. I'm going to show you a lot about Venus tonight. That's going to be the bulk of the program is Venus. It's just about to arrive on your western horizon. I'm going to show you where and when to look, how long it's going to be up, and a little bit about the history of Venus, how it's crossed paths with some major historical things that have happened in the arc of human history. And so that'll be the first part. I also want to just kind of get everybody prepped for the arrival of Orion. I'm going to say it's one of my favorite constellations, and we'll talk about that just a little bit in the second half. And then we've got a couple of things, a little update of the James Webb Telescope and an occultation, a very rare occultation coming up, and Alex and Armand will take those for us. So that's it. We're going to get ready and we're going to get going, and appreciate everybody's kind attention. You've been kind of with us for many years now, and I love that you keep coming back every Wednesday. So I'm just going to jump right into it. We have, I'm working two different kind of computers here, so I'm going to just kind of jump in and see if I can make this work. What you're seeing on the screen there is sort of an alignment of a bunch of planets. And there's nothing really that special about this, but you can sort of, let me get out a little bit. And I'm going to turn on some orbits because it's a little easier to keep track of the planets and where they are when you see the orbits of the planets around there. And I also, I always have to say this because it's important, but I have these planets blown up quite a little bit. This is not actual size. That is the actual relative distances between the orbits themselves. The sun is in the middle. I actually have it dimmed just a little bit because it's so glary. I'll show you that. I'll turn the glare off and you can see. So I just kind of dim that a little bit. I bring the planets up a little bit so we can see them. And I call this kind of thing Planet Watch. And the point here is there's always two things going on. There's what's happening in space. What are they doing out there? What's the relationship? How are they moving? What's their alignments right now? What's going on in the solar system? And then what do we get to see? And that's really sort of one of the special things we can do with this particular program. First, I'm going to whip around. You can see that there's a sort of a direct line between the sun and the Earth right here and Mars. I'm just going to kind of spin around a little bit so we can see what that looks like from the other side. And you see, yep, that's exactly what's happening. So if I can just point this out real quick, the Earth is actually moving in this direction. So it's going to kind of move towards this side. It's going to go around in its orbit this way. Mars is also moving in this direction, but slower than the Earth is. And that's kind of important because at this particular stage, we're just about to become what we call opposition. And that's the point where Mars and the Earth are right in between each other. Or I'm sorry, I should say that a little bit better. The Earth is exactly between the sun and Mars. A couple of things are happening then. First of all, Mars is closer to us than it is in any other time of our orbits, right? That makes sense, right? We're close to it, we're passing, and it's sort of like right there. So it's essentially the shortest distance between the Earth and Mars in its regular orbital period. And so that makes Mars a bit bigger, a bit brighter, And it's definitely something you can go out right after the show tonight. I think it would be great. I'm going to take Luna for a walk. And if we just go out there and look at the eastern horizon, you'll see a big, huge red, bright object. That's it. That's going to be Mars. And then later in the show, I kind of gave it away a little bit, but there's also something happening between the Earth, the Moon, and Mars. And Armand's going to go over that. It's just a coincidence. There's not only this opposition coming up, closest approach to Mars, but there's also a thing called a occultation, where the moon is going to blot out the light of Mars for a period of time. And Armand will explain how to see that. So if you don't mind, I'm going to just kind of like move out a little bit further into space here. Let's just kind of look for the other things. You see Jupiter on the right of the screen over there. And you see Saturn. If I go just bend over a little bit further, there it is. There's Saturn over there as well. So those are objects that are also up in your night sky. Jupiter is still very bright. We're fairly close to Jupiter in our orbit, but we're moving away. So it will continue to be in our night sky for a while, but this is going to get a little dimmer and dimmer and dimmer as we go on. Let me sort of get back in here. And so what I'm going to try to work out is an alignment between the Earth and the sun. And then the story tonight is absolutely about the inner planets. And so you see here, here's the Earth. The sun is in the middle of this scene, and you can see just off to the left of the sun, those are the planets Mercury and Venus. And they're following their orbits, but there's something to remember about Mercury and Venus. In fact, I can sort of show you, let me get my arrow down here. I'll show you everything. So if you draw a line right between the Earth and the sun, right through here, if it's sort of like, just sort of imagine the line there, everything on this side of the line is visible in the evening sky. If these two planets were over here in their orbits on this side, they would be morning objects. And so as they go around and do their orbit thing, right, they're on this side of the sun for a period of time, and then they're on the other side of the sun for a period of time. And Venus does this sort of movement, and it's very regular. And so the thing that we're getting excited about now, let me just get a little bit of a closer view here. If I can do this right. I always get a little bit dicey when I sort of get this close, but I can actually get you to a point here, just a moment here, where you can actually, I'm going to sort of just point this out. This right here is Phoenix, Arizona. Yeah, see that little light right there? You can kind of just see it at the edge of our continent right now. If I sort of organize this so that I put the Earth, or our place on the Earth, just a little bit between, oops, don't go that fast. I'm gonna have to slow that down a lot. If I kind of put it right there, you'll start to see that there is a point where when the sun sets for Phoenix, you can actually see Venus and Mercury above the horizon over there. You see that? And so that's really the key thing. When Venus gets far enough around its orbit to get far enough away from the sun to allow the sun to set below the horizon just long enough for you to see Venus, it will set right afterwards. So the sequence of events is it starts to get dark, sun goes below the horizon. In about 15 or 20 minutes, it starts to get dark enough to see Venus, and then Venus drops below the horizon. And so what we're looking for is that magical moment when it finally appears in the western sky, appearing, coming out from around the sun. And we're looking for that moment. And I think you're going to be able to see it if you've got a fairly clear view of the western horizon. I think we're going to be able to see this somewhere around this weekend, Sunday, Monday, Tuesday, maybe earlier if you've got a really good view of the western horizon, but about that time. And then once it's above the horizon, it's up there for a long time. I'm just going to kind of move forward here real quick. I'm going to take 12 seconds. And I'm going to try to keep the Earth kind of in between the, I let it go. I'm going to just move over this way. Okay, so what has happened? Now I've kind of moved forward. Let me get the scene organized again for us because everything kind of got out of the way. Now you can see the Earth and the Sun relationship, right? And you see Venus is over on the left side still. So that means it's still an evening object. But I just want you to notice something really important about Venus as it's over here. First of all, it has come around the corner. It is now me just get my pointer in here. It came around from behind the sun. It went out to this particular part of its orbit, way out here. We call this the point of greatest elongation. That's its furthest distance from the sun. And that happened about April. And now it's around here, more like May. And now it's around here to July. But if you get a really close look at Venus, right where it sits there, you'll notice something interesting. And I'm going to show you this in the second part of our little Venus feature here. Venus is actually showing phases. You don't get to see this with the unaided eye. With a telescope, yep, you can. You can sort of see that if you get a telescope and you see it, you can see Venus has this little sort of phase shape. It looks like a little crescent moon. But to the unaided eye, you don't see the crescent. Here's the thing. There is this wonderful little trade-off of brightness. So Venus is getting closer to us, right? And therefore, it's getting a lot bigger, right? So from our point of view, it's getting really, really big. And I'm going to show you a chart in a moment that Galileo made about sort of this relationship of Venus, where it is in its orbit and its phases. The point for this particular part of the discussion, though, is this is when it gets really, really bright. And so what we're going to see then is within about the next week, Venus will start to appear over the western horizon. And then it will be with us a little bit higher in the sky every single evening. And for months and months, it'll sort of move through the western sky. It'll get brighter and brighter and brighter. So sometime by about midsummer, it will be the third brightest object in the sky. The sun is the brightest, the moon is the second brightest, and Venus outshines everything else besides those two objects. And it's really, really bright. I love this particular time of year. And there's so much history about this as well. I'm just going to show you this same scene, this sort of same thing going on. Now you've seen what's going on in space. I'm going to show you sort of like what we get to see from here. This is, for those of you that watched the show before, you know I use a program. It's a special little a program called, and I lost my pencil. It's a special little program called Sky Safari 2 or Sky Safari Pro. And what I'm looking at here is the western horizon. We'll zoom in just a little bit. And everything in green is out of the sky below the horizon. Everything that's above it, right? Sort of you see the sky in the background. And clearly you can see Venus and Mercury, just like my original scene. The first thing I showed you, sun behind the earth, Venus and Mercury right next to each other in the sky. Now I'm going to just kind of do something real quick. I'm just going to move forward. So this is tonight, and this was tonight at about 5:30. The sun was below the horizon, and I'm just kind of using this location because I think the sun is far enough below the horizon that we probably start to see these two planets. At least for sure you'd see Venus, but you have to be able to see the horizon. This isn't above people's houses. You got trees in the way, you got city in the way, you got all kinds of things in the way. So, but as I go forward just a little bit, I'm just going to show you several things here. Watch what's happening. Mercury is getting a little tiny bit farther away, and Venus is getting a little bit higher. So this is a week from Sunday. This is December 11th, a little bit higher, a little bit higher. And eventually Mercury is going to reach a point where it comes around its orbit because it's moving a lot faster. And oops, there's the moon coming in too. That'll be kind of cool. This is, let's look for this. This is Christmas Eve. We see Venus, Mercury, and a very, very new crescent moon. That'll be something to look forward to. Sort of, that makes Christmas even specialer. And then there's a point where Mercury and Venus trade places. Mercury will then dive right back into the horizon and go right in front of the sun from us, and Venus will just get higher and higher and higher and higher. I won't go any farther than that, but that's essentially how this works. And in history, people have known about this. And so I'm going to point to about three big, huge places in the arc of human history where Venus and our historical record have collided a little bit. And I'm going to start with Mayan culture. So this little thing I put on the screen right now is from what we call the Dresden Codex. And if you know Mayan culture a little bit, remember this is Mesoamerica, this is sort of Guatemala and southern Mexico, and the fluorescence of this particular culture was about 1100 AD. So in Europe, we've got the Middle Ages, and we've got sort of like just sort of people sort of getting to know tables in the sky and that kind of stuff in Europe, and then we have the Mayan. These are not connected connected. These people are not talking to each other. But these particular pages from that codex are called the Venus pages, or the Venus tabulation, or the Venus, there's another word for it. I'll think of it in a minute. Anyway, very, very important, because when we first discovered these codices, this one's called the Dresden Codex, and it's the most important codex, and it's the most important. We recognized that all of these sort of pages, this was all about the movement and the timing of Venus. If you know your sort of your Mayan lettering and stuff like that, you can see on the right side all those little dots. This is like number 4, and so you can't see in my line, but I can see sort of the number. Lines mean 5s and little dots mean 1s, so you can add them up. And what this was is essentially the day count timing between the milestones that Venus has in the sky. And they were able to sort of record when this thing is going to appear, how long it's going to appear in the sky, sort of what it's going to do, when it's going to go away, and for how long, when it's going to come back again. And this is really, really sophisticated stuff. This is observation compared to day counts, and they did it better than anything. One other thing, this is sort of not, I was trying to find a glyph sort of in situ, but this is sort of a little diagram of what the Mayans used as a glyph for the symbol of Venus. It, again, is the brightest star in the sky, so it has prominence automatically. And so we see this sort of cross glyph. One of the interesting things, I ran into some colleagues that are working on petroglyphs here in Arizona, and they claim to have found this particular glyph also in a little petroglyph site called Sears Point, and it's right by Gila Bend, Arizona. And so we're trying to put together the sort of relationship between Native American cultures up here in Arizona, Four Corners region, and Mesoamerica. We know there's links, we know there's cultural links, but sometimes it's very, very difficult to find the sort of like the timing in those links. So we're kind of excited about this. The Dresden Codex is telling us very specifically what the Mayans knew, and then we sort of have this relationship, maybe even with Arizona, if we're right that this particular glyph has made it this far forward. So that's kind of cool to think about. So that's the first thing. The next thing I wanted to kind of show you is much later. Everybody sort of recognizes this guy. This is Galileo. Galileo was the first person to use a telescope, and one of the things he used his telescope for was to look at things in the sky that nobody had ever looked at before. Of course, everybody knew Venus was a planet, and of course, everybody knew its characteristics by the time Galileo came along, but nobody had actually seen what I was talking about before, the phases of Venus. So this is really important. This is really extracted right out of Galileo's tabulations, and this is part of his book and his record. What he's showing here, really from the right side to the left side, is not only the phasing of Venus as it comes around the corner and gets closer to us, just like I showed you as Venus was moving through its orbit, but also the size difference. Look at how much it grows between being a full Venus right next to the sun. That's what we would see if we're going to look at it in the next month or so, all the way up to that point, sort of next July and early August, when it's a slender little phase Venus. And the relationship between the brightness and the closest and the phasing and all of that stuff relates to each other. This was one of 3 phenomenon that Galileo noticed that actually changed the way we see the universe. Before this, we never thought planets and the moon had what we would consider terrestrial features. And so he took a look at the moon, and he could actually see mountain ranges and things on the moon. First time that's ever happened. He also famously, looked at Jupiter and saw the orbits of the Jupiter's moons, Io, Europa, Ganymede, and Callisto. We now call them the Galilean moons for Galileo. But that's the first time anybody sort of had ever written or witnessed and noticed and was able to catalog the movement of something around another planet. And then with this, Venus, the third of his major discoveries with the telescope, that Venus was phasing, he could determine that Venus was actually an inferior planet. He could determine that Venus was actually going around the sun, not the Earth. And it sort of related all to this big, huge revolution of understanding that we aren't a geocentric solar system where everything goes around the Earth, but we are a heliocentric solar system where everything's going around the sun. And this was really one of the monuments that did this. So I just love this juxtaposition between the discoveries that are happening in Europe and what people are doing across the world, especially in Mayan culture, and all sort of related to the same thing. Finally, right, there's more stuff going on here. I'm just going to show you, let's see, I'll show you this image. I'm going to get rid of Galileo. You don't need that anymore. This is an image from the surface of Venus. And so the short history here is that after the Cold War, after World War II, everybody kind of remembers the 50s when USSR and the United States were in the space race and everybody was trying to be the first at things. Russia themselves, or USSR, invested a whole bunch of money and a whole bunch of energy in trying to get landers and get things onto the surface of Venus. They were somewhat successful, but they had to try and try and try. And the development of their spacecraft, they called it the Venera spacecraft, and there was a Venera 1 through 17, if I remember correctly. This particular image is from one of the Venera missions, Venera 13. This spacecraft actually was able to land on the surface, and they actually were able to get pictures. So this is actually a Russian or a USSR made, SSR made spacecraft on the surface of Jupiter. It was able to transmit for only about little less than 2 hours. So there are all kinds of missions and all kinds of ways to understand Venus, but a lot of it is testing the instruments and seeing how long they're going to last before the turbulent, really, really hot, really, really high pressure environment of the surface of Venus would essentially just destroy these instruments. They can only last so long. This one lasted almost 2 hours before it went dead and we didn't see anything. So pretty exciting. Getting onto the surface is not easy. I have another image here. Let me see. I'm going to do this one. So Venus actually has two faces that they show us. And let me just sort of get these things set up. This is actually Venus on our magic planet, right? In the lobby of our building. And that young man helping us out tonight is Benjamin. Benjamin is the son of Professor Craig Hargrove. I hope you recognize the name Craig Hargrove because he is the principal investigator on the Luna map, the one that just launched on the Artemis mission. We've talked about it a lot on this show. I said we had some festivities around campus today, and young Benjamin was there, and he's helping me with my program. What he's showing us here is a Venus of cloud tops. And so Venus, to look at it either in a telescope, you can see nothing but sort of the surface of clouds. If you fly by it and you look in visible light, you can see nothing but clouds. It's really, really, really thick, layers and layers and layers of clouds. The atmospheric pressure on the surface of Venus is hundreds of times that of the Earth. You couldn't stand there. You would be crushed, right? And these clouds trap heat. So Venus completely around, both sides, all the way around, all the way from Venus is a ridiculously high temperatures. It's in the 500 degrees level. So like if you had a pencil on Venus and you could stand there and not get crunched, the lead would melt out of your pencil. It's that hot. So you can imagine why it's so hard to get down there with landers and discover things. But there is a way. We have also, let me sort of put another image up here. So now Benjamin has changed our view here. And now what we've done is we've pulled the clouds away and you can see that Venus actually has features. And what we're doing here is we're looking in essentially X-ray, but other technologies as well. So this is a compilation, this sort of Venus was made by a compilation becoming a whole bunch of things. So there's some of this is USSR information from flybys and penetrating the clouds as much as they could. There are 2 NASA flyby images that are making this composition as well, but you can't look in visible light. All you see is clouds. If you look in infrared, you can start to, I'm sorry, not infrared, but in X-ray, you can start to see right through the clouds. You can see that there's features. You can see that there's things changing changing on the surface of Venus. It's really, really intriguing, but also extremely hard to understand. It's really hard to get there. It's very expensive and tough to sort of put together. So those are sort of the things I wanted to show you about Venus. Here's a sort of a bigger sort of picture. This is what Benjamin would be seeing if he were like right up against Venus, and I can show you. Doesn't that look sort of like really, really like a hostile environment? So think about this for a second, sort of the difference between Venus and Mars. They're both our neighbors, right? As far as getting to them, they're both roughly the same distance as you go if you go at the right time. But Mars has a very, very thin atmosphere and has a solid surface. And we have landed all kinds of instruments and crafts and rovers and things like that. We've driven around Mars. We have things there right now. ASU is running projects on Mars right now. All of that stuff is going on. But Venus, a lot harder. Now, there are some missions coming up. And so in the future, we'll be able to talk to you when you sort of like come and see our facilities and learn about some new missions. We have some researchers that are working on projects that are forward thinking about how to take the next dive and the next step as to joining Venus in the sky. I can't wait. We'll have to see how this all works and how it comes out. But we've got lots of work to do, and we'll see what happens for you and for us, and for what we can do right now. Just check it out. I want you to kind of go out, look at the night sky. Let me just go back to today, so you sort of remember where everything is supposed to be tonight. There you go, and remember, sort of just going to leave you with this view. Here's the Earth. The sun's in the middle. Mercury and Venus are just going to start above your western horizon as they're moving in their orbits. Let me just show you with the arrow again one more time, and then we're going to take a break. So if I can show you, so Mercury is here, and you can see it's going to move around this direction. It won't take very long for it to get out to the end of its orbit. When it's out at the end, its greatest elongation is only about 18 degrees in angular distance from the sun, and then it'll start to fold back again and go behind the sun. Venus, on the other hand, will be up here for a while. So how long does it take to do this? Well, Venus actually is above the horizon for quite a little while, about 40 weeks, and then it goes between the sun, and then it's invisible for us for about 8 to 10 days, then becomes a morning object for another 40 weeks, and then goes around behind the sun. That takes longer, about 70 days, and then another 40 weeks. And it's a process that's been going on for years and years. One more thing I'm going to mention about that and how that works. And the Mayans knew this, and with a further examination of the Dresden Codex, we were able to determine that Mayans were able to actually figure this phenomenon out. The number of cycles when Venus does this whole range of things, appears on your western sky, goes around, disappears, goes on your eastern sky, comes back around again. It does that 5 times in 8 years. And then it starts the whole cycle again. And it's very close to the same time. So 8 years from tonight, right? 8 years from November 30th, 2022, right? Will be November 30th, 2030. We could be having this same conversation. I'd be telling you about Venus. I'd be telling you about it arriving on the sky in the same time of year. And that means Venus has 5 times where it sort of appears in the sky, does a little dance in the western sky for 40 weeks, and then goes back and repeats that same process over again 8 years from now. That's pretty exciting. And ancient cultures were able to know that. All right, I'm going to stop there. That's what I wanted to show you about Venus. We're looking forward to it. And then we are also, yes, one more thing. I thought about this. We're going to meet again in about 2 weeks, right? So we will be back on the show 2 weeks from now. I am sure you're going to be able to see Venus from wherever you are in Phoenix within the next 2 weeks. And so if you could check it out, I mean, this is a really cool thing for you to do. If you want to just kind of go out, just make a point to get out at sunset, just like let the sun just get out of the way a little bit, let it start to darken, look at the western horizon, and just note the day that you actually sort of see it for the first time. And then what we'll do in 2 weeks is we'll set up a little poll. We'll just ask the audience. I saw it on December 4th. I saw it on December 7th. I saw it first on December 9th. We'll just see how how you guys do and sort of that stuff. So there you go. You got a 2-week assignment. You got to go out every single night, look for Venus, mark the first night you can see it, and then we'll come back and check that out on December 14th when we get back together. All right, I'm going to kind of turn the microphone over to somebody else for a little bit. I'm going to invite Alex to come on. We've got some poll questions for you, and we'll see how well you do here.
All right. Thank you, Rick. Yeah, so let me pull up these poll questions real quick. We have 3 questions for you all. Number 1 is, when does Venus appear above the western horizon? Or when Venus appears above the western horizon, how long will it be visible? Then you have number 2, Orion is a character from Eastern Mediterranean mythology. What is he? You have a couple options there. And then finally, Orion holds something in his left hand. Is it a blank? And then you have 4 options there as well. So be sure to answer those while we take some questions. The first one, Rick, is, what type of planet is Venus and why? And this kind of ties into another question that's been asked, but this is a good one.
So we categorize our planets in big, huge, broad categories. And so generally the best way to describe our solar system is that the 4 inner planets, the inner solar system, are what we call terrestrial. That means they have a solid rock surface. And so theoretically, if you could overcome the clouds and the heat, or theoretically, if you could get to Mercury and then overcome the heat and the cold, you could land something on it, you can drive around on it, same as Mars. So those are terrestrial planets. They're essentially formed out of the same stuff, and the characteristics are the same of the 4 inner planets. They have the same kind of minerals, and they have probably the same formation story amongst themselves. In our solar system, the next 4 out, the big huge giants, are gas giants. There is some sort of solid center of various sizes and densities for each of them. But for the most part, the surface that we describe of Jupiter, Saturn, or whatever is actually just a sort of a cloud, just sort of a non-solid surface, gaseous as opposed to solid. And so that kind of distinguishes those different kinds. I would add another one. Some people call them dwarf planets. I kind of like the term Plutoids, but just outside of the orbit of Neptune. There's a whole bunch of objects out there that are sort of both rocky and icy, and they're very, very small, and they have funny orbits. They're more elliptical than the inner 8 planets, and they're also tilted to the solar system. So there's another category. And then there's another type of object that we're kind of excited about, and it's a metal-rich world. And you'll hear more about this next year, but there's an asteroid called Psyche. You've heard us talk about it a little bit. We're launching a mission to go visit Psyche in October. And it actually is something a little bit different. It's not necessarily rocky, but it has a high concentration of nickel and iron. So we believe it was probably a planet, maybe like Earth and Mars in formation, but it got hit or obliterated by something else, and it kind of left it with this funny, really, really iron-rich core. So it was on its way to being a terrestrial planet, but it sort of got kind of hit, and it's now this funny hybrid or a little metal-rich object out there. So that's kind of it. And then what's the second part of that question?
That was the full question. You answered it perfectly. So
did I answer both of those, sort of the double of it?
Yep, you got it.
Are there any more, or are we going to finish off this poll?
I think we're going to share these poll results. We kind of got all the responses in. You're going to have to tell people who are right, because some of these even might have tricked me. So the first one, we had the majority. It was actually, we were tied between 91 days and 280 days.
So if you remember, when I was having the conversation, when I was actually talking about it, I said 40 weeks. And I don't know, so that kind of relates to more like 280 days, if you sort of figure a week is 7. So it's actually up there quite a little ways.
Yeah.
40 weeks is what? That's almost about 9 months or so. In fact, some people, just sort of saying that reminds me, some people think that ancient cultures also understood a relationship between the visibility of Venus and the gestation period of a human being. So you're pregnant for 40 weeks, Venus is available sort of in the sky for 40 weeks. And so there is a relationship there as well. So in the conversation, I said 40 weeks, it's actually, kind of plus or minus several days, but about 280 days above the horizon. And so that kind of tricked you a little bit. there, but that's all right. It's up there for a long time. And that's why to sort of like get excited about it arriving, because it's an object. You're just going to, after about the middle of December, you're going to see it every single night for, almost most of the year next year. So that'll be kind of cool. What about this other thing? So yeah, there's archers.
Orion, we got the majority saying a hunter, which is what I've always heard him as, Orion the Hunter. Are they
That's
right?
that's it. He's going to be a hunter.
All right, they got it spot on. And then the last one, Orion holds something in his left hand. Is it a bow? The majority said bow. Not many people picked a dead rabbit.
that was me. No, I'm kidding. No, actually, it is a lion pelt, and there is something of a story about Orion. And I'm going to show you a little bit about how to find Orion in the coming week as well in the next thing. So as soon as we close out this poll, I'm going to kind of relaunch my pad here and sort of show you where to find Orion, and then we'll go to another segment. Okay.
All right, well, it's all closed up. You got a lot of great answers. You got some tricky questions, made
I
people think.
know. See, this is what happens when you sort of like make people sort of guess. And so learning about Orion, some of them got it right. Yes, a lion pelt, and that's what it is.
All right.
So let me just show you this. I can kind of turn on my little iPad here. I'm going to turn it sideways. Maybe this will be easier to see this way. First and foremost, I went too far ahead. So I'm going to go back to now. And you're going to see, I wanted to show you something about Mars. And you're going to see this again in a moment. My pencil. And what you're going to see is Mars is actually sort of tucked into the constellation of Taurus, and it has been for a long time. When I looked at Mars a couple of days ago, it was actually in the area right in between. Let me see, I guess I don't have a pointer available to me, so I can't show you. But you see the two stars to the left of Mars, or one of them associated with the constellation Orija, and the other one is sort of the 2 points of the horn. It was actually closer to there, kind of in the goalpost. And it's moving backwards towards the head or the V. And that's because it's in this particular time when we're passing by Mars, Mars shows a retrograde motion. So as we're going by it, we're going faster than it. So against the background stars, it looks like it's going backwards, and it's kind of like right in the middle. That retrograde motion starts about 2 months ago. It will last for about another 2 months, and then it'll start moving in the right direction again. So it will spend a lot of time in Taurus. And Taurus is just above the eastern horizon now, this time of year. And I was out walking Luna the other day, and we were out, and I saw it, and it's absolutely just like I described. Big, beautiful. It's red. It's going to get a little bit bigger over the next week or so. And watch it, and watch the relationship between the head of Taurus and Mars. And I think that'll be really, really cool. What I really wanted to show you is just right here down on the horizon. You see this guy coming up here? This was at 7:30. This is right now. This is where it is. So I'm going to move ahead about an hour or so and watch what happens. So here is Orion right dead in the middle of your screen. And you can see that the big red star in the left side is Betelgeuse. That's the shoulder of Orion. The blue star that is sort of his other shoulder, if you want. You can imagine an arm sticking out. And you see that little trail of stars there. There's a little arc of stars towards the top of your screen there. And that's what a lot of people think is a bow, or a bow and arrow, or something, or a shield, or something like that. But no, the story is that you'll see this in antique artwork, that's actually a lion pelt. And the idea is that lions were the chiefs. They were the big ones. They were the king of the jungle. They were the ones that sort of had the biggest, most power. And if you were a hunter and you could slay a lion and then take his pelt, the pelt itself became projection or protection. And so in his right hand up there, he's holding a big club up over his head. In the left hand, he's holding out in front of him this lion pelt. You can see the iconic belt stars. That's Alnilim, Alnitak, and Mintaka. Those are sort of the three little sort of blue crystal stars that hold his belt together. The bright star, kind of about where his knee would be, is Rigel, and the other bright star, the other star is Saph. They're easy to see, they're easy to find. Orion has a million stories behind it. It's one of everybody's favorite constellations. So you'll see it right now, right after the show, go out and find it. It'll be above the horizon by then, and start to watch for it, because now that it arrives in the sky, sort of like Venus growing away from the sun in the western side, Orion is going to grow away from the horizon on the eastern side. And so by about the end of December, the middle of January, Orion, in the middle of the evening, at the best time to look at the sky, is standing straight up, straight to the south, and dominating everything else in the sky. So welcome Orion, and there it is. I am now going to kind of close out the star part of our show, and I'm going to ask Alex to come back. And we've got so the gift that keeps on giving is the James Webb Space Telescope, and there are some new images, and I wanted Alex to kind of go over and show you what's there and how to find them for yourself. You should be looking at these yourself on your own time too. Sure.
Right. So thanks, Rick. I think you have you actually have James Webb in the program, don't you? Right? You
I
have
do,
it
except
in the palm of your hand.
I do, except I'm going to have to actually go get it up again. So it's going to take a minute, but when I have it ready, I'll show you.
Okay. Well, then I'll start with the site first. So James Webb launched back at Christmas of last year. It's been taking great images ever since. It's been just showing us so much about the universe around us, planets, stars, other galaxies, and the entire universe. It's been taking great images. How do you begin to find all these great images? Because they always get posted on socials, but if you want to just find everyone you can, here's what you do. You go to jwst.nasa.gov. This is the Webb Space Telescope's official site on NASA. You have a lot of great information here, all this information about the engineering of it, and a whole bunch of other stuff. But the thing is you can go and click this latest tab right here, and it'll bring you to this entire Flickr page, which has every single image that James Webb has publicly released. And we just want to talk about some of these because we need to catch up. It's been a while since we've caught up with all these. Yeah. So this is one that we talked about about a month ago. This is the ASU image, but we've had some ones since then. If anyone knows the famous image from Hubble Space Telescope, the Pillars of Creation, on the left, what you're seeing is the one that Hubble took, and now on the right, the one that James Webb took just within the past month. You can see some differences. Very similar shape. I wouldn't too focus on much on the different of colors because the colors aren't really what we'd see as a human eye. But the main thing I want you to look at is just how many more stars you can see, how many little points of light you can see. And that's because Hubble is a visible telescope, and all of the dust and gas in the Pillars of Creation is very thick and opaque to visible light. So it's like a curtain across a lot of these stars. Infrared light passes right through it. So when we use an infrared telescope like James Webb, we can start to see all the stars that are forming in these clouds of dust and gas. And we can really understand what's going on inside the actual pillars themselves. Another thing I have to point out, just because one of ASU's own professors, Dr. Roger Windhorst, likes to point it out, is you can see on each of these little tips of the actual nebula, you can see stars that form, and these are actually stars that just formed right on the edge, and then all their wind from all the radiation pushes away the gas cloud and just leaves them sitting right on the top of those pillars. So this is one of the big images that was released recently. They also did a Halloween version of it. Here's the Halloween version of it in the nice kind of ghoulish gray and orange. You have some great pictures of some merging galaxies. These are two galaxies that have collided and are merging together, just like our own Milky Way will do in about 6 billion years. You have some really, really big star fields. So this is the Spitzer Space Telescope, way even before Hubble. And then here's Webb. So you can just see the amount of detail that we're getting in the same area of the night sky. We can start to see, like this galaxy, you can see these swooping arms coming off of it. Where on Spitzer, it's just a blob. You can't even begin to see the shape of that. So very interesting. We also have some nebulas as a new star forming with all this hot gas shooting out of it. Very pretty image, all these nice vibrant colors. So we're just getting some great pictures in Webb, but I encourage you to go to the website and learn more about these. We're looking at exoplanets. We're detecting sulfur in atmospheres around other worlds. So just be sure to check out all these different images because we got so many that are coming out all the time. We're just looking forward to almost every single one. Even though they're not all our images like the one we shared with you earlier, this is just a great resource to always keep up to date with that telescope.
Good, and we actually have two teams at ASU that are kind of just working on different parts of science with James Webb too. So it's really close to home at ASU, and we look to have some really cool stuff coming out in the next couple weeks to a month or so. So keep checking. But I want everybody to sort of just realize that this is a great website, and when the images first started coming down, everybody was like, "Oh, these are amazing! This is so amazing!" And now there's just more and more and more. They're still amazing, but they just keep rolling out. You might not
Yeah.
hear them as at press releases much anymore. But I keep
No.
checking because it's amazing. I do have it on the screen. You want to look at it?
Oh
Real
yeah,
quick?
bring it up.
Let's see if I got this. So I know this was a long time coming. I don't know why it took us so long to do it, but we finally found a really cool model of the telescope, and we were able to sort of like just kind of get it organized and into our system here. So I'm going to just sort of tell everybody sort of in the future, coming in the next year, we're going to really prioritize getting the building open again. We have this wonderful theater called the Marston Exploration Theater, and the system I'm showing you right now, what you're seeing on the screen, is essentially the system that operates the theater. And this object here, this model of the James Webb Telescope, is in like 3D. So you wear these little glasses and you can see it. You can kind of like you can let it like fly around you and all of that kind of stuff. It's really a super cool experience to learn about it. Anything you want to say about this instrument, Alex, while I got it up here?
I mean, I just have to say, we talk about it so often, but we knew James Webb was going to be better than the telescopes we put up in space. That's why we built it. But the fact is that almost with every image, with every scientific data set that we're getting from this telescope, we are just constantly being surprised by just how good it is. I just think, especially here at ASU, but just everyone all over the world is so excited. And this is kind of going to be the next big thing for hopefully at least another decade. This is kind of the going to be the telescope. This is the images that, just like the ones we got with Hubble that we have in our textbooks and that we have like on in our walls and posters. This is going to be the thing that's going to be supplying those decorations and education for the next 10 years. It's really the next big thing. It's exciting to be talking about it right now in the middle of it.
I think you're totally correct. Very good. All right. Anyway, James Webb Telescope update, and we'll see some more stuff coming up. Watch for it over the holidays. I think you're going to be surprised. Let me see, Armand. There's something really unusual coming up, and I guess let me get rid of this telescope, and why don't you come tell us about this amazing occultation that people can go look at?
Yeah, thank you. There is a really amazing occultation coming up soon, next week actually. Let me share my screen and let's get started. So Mars is going to be occulting the moon next Wednesday. But what does occultation even mean? Well, it's basically when one object is hidden from us, the observer. One object is hidden behind another object. And it's essentially the same as an eclipse, but of course, in this case, you don't need any special glasses to see it. And in this case, the moon is going to be directly in line between us and Mars, and it's going to occult Mars. And as Rick mentioned earlier, Mars is actually at what we call opposition right now. And we know that Earth and Mars have different orbits. Mars is a bit further away from us, and so it has a longer orbit around the sun. And so every couple of years, the sun, Earth, and Mars line up. And that is when Mars is at opposition, basically when Mars and the sun are at opposite parts of the night sky. And this is also when Mars is closest to us. And so we have the best view of it from here on Earth. And occultations are also used for science as well. When we look at stars and exoplanets specifically, when an exoplanet moves directly in between us here on Earth and its host star, it does something called a transit. It blocks out some of the light coming from the host star. And we can measure specifically how much light is being blocked out and for how long. And we can use that to find how big the exoplanet is and also how long its orbit is around its host star. And when the light from that star shines through the exoplanet's atmosphere, we can look and analyze that light to see what their atmosphere is made of, as Alex was mentioning earlier with Webb. So when do we actually get to see this opposition or occultation of Mars and the moon? Well, we can only see it in certain parts of the world. So if you're in northern North America, you'll be able to see it. If you're in Western Europe or in the north of Europe, you'll be able to see it, but nowhere other than that, unfortunately. And you'll be able to see the occultation at 7:30 Mountain Standard Time here in Arizona next Wednesday, December 7th at night, and it'll end about an hour later. So go out next Wednesday night and watch this pretty rare event, considering that Mars is at opposition and there's a full moon as well. And so we can see Mars going directly behind the entire moon and emerging from the other end next Wednesday at 7:30 p.m. Arizona time.
Great, thank you, Armin. I'm going to look for it. I'm going to try to image it because it's only, did you say it's only going to be behind the moon for about an hour?
Yes.
So we'll watch it go behind, and then about an hour later, it'll pop out the other side, right? I mean, that's kind of how that might work. That's good. I remember one time, a long time ago, I watched one that was an occultation of Venus, and it was really pretty amazing because it was actually during the day, but with a telescope, it was bright enough to see it. And Venus was phased like it was in that drawing, like Galileo had. And what poked out first were these two little dots. The two ends of the arc kind of came out, and they looked really strange because that didn't look like Venus. And then as it sort of like moved away from the surface, you'd see the whole sort of rest of the arc coming up. And I still remember that. Gosh, that must be 30 or 40 years ago. That was when my kids were little. So very cool. Thank you very much. So we might actually end up early, but not usually. I still have some announcements to make. So in 2 weeks, we are going to be doing a broadcast. It'll be the last one of the year because we'll kind of close down for the holidays. So December the 14th, we'll be back with you. It's a regular Wednesday night thing, but 3 of us are actually going to be in Chicago. And the reason for that is there's a big, huge thing. It's called the American Geophysical Union, AGU. And that is basically the main world congress. That's the biggest sort of meeting of geologists, geophysicists, a planetary scientist, and others, and it's the biggest one in the world. And so this year it happens to be in Chicago. ASU participates, and especially the School of Earth and Space Exploration. What we do is we have a big, huge booth set up on the trade show floor, and we have little lectures and speeches and demonstrations and things. And so it's our chance to sort of like rub elbows with geologists from all over the world and planetary scientists as well. NASA is there with a big, gigantic booth. And so what we want to bring to you on that particular program is we're working up some special presentations like usual. We one of the young people from L Rock that is a researcher, Tori Roseborough, is actually going to be with us in Chicago, and she's preparing a little update about sort of what's going on the moon and some of the missions we're working on there. We are also going to kind of show you some scenes from the trade show floor. We hope, right? We'll be there. We'll try to put this together. And I've also made contact with one of the outreach people from NASA. They are also there in a big way. And so we're kind of just trying to hope to work out the timing so we have an interview with some people that we wouldn't otherwise get to meet and have on the show because we're there. So that'll be kind of cool. I just noticed that Kim is back. Thank you, Kim. And Kim, also remember 2 weeks ago, was in Florida for the launch of the Art of Talk. Kim, do you want to say anything? I know you're sort of like, I think Kim has been scrambling ever since she got back from Florida to sort of like get caught up. And so
I have been scrambling, and so I'm giving updates on the Lunamap blog every week. So I would say check the NASA Lunamap blog for the latest for what we're doing. And all good things. And Craig's keeping me busy with updates, and then I send them over to NASA and they publish them for us. So
That's excellent. So good.
yeah, so it's all good. And then I'm getting excited to go on the road with you and take the show to Chicago with
Take the
Alex. So it's
show
going to be
to-
fun.
Alice is going to come with us. I think it's Kim looked at the long range forecast. I guess it's going to be 30, 29, 30, 32 or something like that when we start to arrive. So we'll see. We'll try to get out on the lake a little bit, or maybe not. We don't have to leave the building, if I understand our.
I think we should do the
Thank
program
goodness.
outdoors.
Yeah, I guess not.
Bite your tongue.
So last week of school, finals are next week. We'll see you the next week after that from Chicago. I really want to re-encourage you to sort of like keep looking at some of these resources, or go back and look at some of the information that we have sent over the years about over the programs, about sort of where to find some of this on your own. The web thing is absolutely amazing. Whenever I have a break, I look for it. It surprises me every time I open it, because every couple of days there's this new image and a new sort of science coming out of web. And so lots going on. And so I'm going to go ahead, and unless anybody has anything else to say, I know Meg joined us also since we've been gone. Meg, how was the party tonight?
Well, Rick, of course, it was
I have-
awesome because there's so
I-
much to celebrate.
Surprised her.
We're glad to be here. I want to give a shout out to Tracy Dodrell and her online students that are
Okay.
here from Scottsdale Online. Tracy has requested that the LunaMap link be placed in the chat. And so as if
Yes,
by
it's been
magic, I
sent.
thank you so much, Alex. And we're glad to be here, and we appreciate everyone that's joined us for these virtual night sky experiences. Thanks, Rick. I'm handing it back to you.
Gosh, okay, so we got lots to look forward to in December. We're looking forward to the holidays and keep looking at the night sky. I should also say that with the arrival of Orion, a lot of the brightest stars in the sky are also coming up with it. And so I just love, in the really, really cold, kind of crystalline skies of the middle of winter here in Phoenix, where it's still warm enough you can go outside and enjoy it, yet it's still cool enough that the air has cleared, it dries out in the middle of winter, and the brightest stars come out. So we've got lots to look forward to. I'll see everybody in 2 weeks. Thanks for joining us, and I really appreciate your loyalty, and I appreciate you to come back every week, and keep an eye out for Venus. See if you can see it the first night you can see it. We need to know. Okay, thank you, everybody. Good night.